Hello everyone, welcome back to MATLAB programming class. Today we're going to learn how to do integration, both indefinite and definite integrations. And it's going to be very useful because there are tons of applications out there that we require to find the derivation, the integration, and do particular calculus-based operations in our problem in order to solve it. And today we're going to learn one of the most important ones, which is integration. Let's get us started. The way that we define integration in MATLAB is through a function called int. Before that, let me create a function, call it f1 equals. Let me put it in line exponential of, let's just start with something easy. Let's go with x. I define a function called x, and what's the variable? Also x. I can easily pass values to that like 3, and there is going to be 3 because it's a linear function. The integral function equals int of, and we define it like that, f1 of x. This is our function, f1 of x. And now we need to tell MATLAB what is the d of x, the second part, because each integral has a function and a d of x part which indicates what is the value of concern in that particular integration. So we can do it by passing x to it. If you do that, you see an error. The reason is not that we did it wrong or misspelled something. The reason is MATLAB does not understand what x is going to be. And it is expected because if you look at the workspace area, you see that there is no x. We do have a function, and that function has x in it. It is totally fine when we come to calculating the value of that function for a particular x. However, if you wanted to perform some symbolic calculations, we need to tell MATLAB that we're dealing with a symbol. So let's do that. I define sims of x, and if I hit enter, you see that the x now is created. So let's do the calculations again. I come here, and if I hit enter, MATLAB calculates the integral, and I can easily pass the function, and you will see that the famous x squared over 2 is simply calculated. Now we learn how to calculate any function and the integration of any function in MATLAB. Let's go and calculate some more. So I put home, I call it f2 in line of, let's go with something parabolic, sine of x plus 2 cosine of x. And what's the variable? It's going to be x. Now I define a new function called f2, and it is symbolic because x is defined as a symbol. Now I can calculate the integral equals int of f2, and what's going to be the x? The d of x is going to be x. So if I calculate that, you see that MATLAB has no problem deriving the function. At this point, I wanted to show you something, and I'm going to bring the last calculation I've done. This was the last part. In our function, in our defined function here, the only variable we're dealing with is x. There is no y, there is no t, there is no z. There is no other variable in that function except x. Therefore, MATLAB already knows that the only variable we're dealing with is x variable. Here, we can simply get rid of x because there is no other option. If there were like other variables, x and y, then we had to define which variable we're talking about. But here, we're solely interested into x, and MATLAB is smart enough to understand that part. So if I hit enter, MATLAB has no problem calculating the function for us. So with that said, let me bring a new screen. And using home has the ability that if you wanted to see the calculation before, you can just scroll up and see what were the last calculations. In this part, I'm going to create a new function, and this time I'm going to put more than one variable here. And let's go with x multiply y plus sine of x I'm going to calculate something big. Let's go with x plus y minus tangent of y plus 3 exponential of x cubed. So as you see, this is really a hard integration, and also it has more than one variable. It has x and y. So let me define our variables as well. This is going to be the function. Again, there is no y here, so if we go and calculate the value for integration, we receive an error. So let's go with sims of y. Now we tell MATLAB that there are more than one variable involved. So let's go with an integral function equals int of f3 x and y. And now, because we do have more than one variable, we need to tell MATLAB which variable is important for us. Is it x variable that we wanted to take integration according to, or is it the y variable? So this time, let's go with x. I tell MATLAB that I know the function has x and y, but I want to take integration for x variable. If I do that, pretty of integral, and you see that MATLAB very easily calculates a very hard integration for us. Now let me bring the last calculation. This time I put y, and MATLAB calculates it as well. Pretty integral. It will calculate it. So you see how productive MATLAB can be in very complex calculations. And when we learn how to work with MATLAB, it's going to be really fun experimenting with different complex functions, testing your theories, and honing your skills. Up to this point, we've learned how to do indefinite integration. Now we need to know how to do the definite integration. As a matter of fact, it's very easy to do that. Let me clear the screen. I can go and bring f1 function that we created. It was the linear one. And integral equals int of f1 of x. And now I wanted to tell MATLAB go and calculate the definite integration. As you know, the definite integration has two limits, the lower and the upper limit. And now I can easily tell MATLAB that I wanted to calculate from 0 to 1. And MATLAB has no problem calculating for us. Or I can do it like minus 12 up to 5.8. And you see that MATLAB has no problem calculating. Let me bring the f2 function here. F2. So this was the function that we worked with, and integral equals int of f2 of x. What are going to be the limits? It's going to, let's go with -4 to 19. So the lower limit, we do have only one variable. The lower limit is -4 and the upper limit is 19. The MATLAB calculates it. As we learned before, the results are in radians. These are not the degrees. And if we need to know the real value, the result in decimal format, we can go double ans, and it will bring the result to 3. Finally, let me bring the last function with it, which has two variables. And if we go with integral f3 of x and y, and now the integral is going to be int of f3 of x and y, and then what's going to be the variable is going to be x. And if I do that, I can find the calculation as before. I can bring it up and go with -1 up to 4. Let me make it more clear. Pretty integral. So if I do that, it's going to be a big one, but you can notice that MATLAB understands this is the range for x, because the y variables are still in there, but there's no x, simply because the x variable were substituted by these margins. And one time it's calculated as the lower limit with -1, the other one with upper limit.